Welcome to our deep dive into the groundbreaking discoveries made by the James Webb Space Telescope. We're about to embark on a journey to the very edge of the observable universe, to realms where light has been traveling towards us for over 13 billion years. And what we're finding there is, to put it mildly, mind-blowing. These findings are shaking up our understanding of the universe and challenging the standard cosmological model. We're seeing things that were thought to be impossible, galaxies that shouldn't exist, at least according to our current understanding of how the universe evolved. Fasten your seatbelts, folks, because things are about to get really interesting. So, picture this: the Big Bang, the grand event that set our universe in motion, happened roughly 13.8 billion years ago. That's a long time ago, right? Now imagine looking back in time, almost to the very beginning, to a time when the universe was just a few 100 million years old. That's exactly what the James Webb Space Telescope is doing. And what it's seeing is incredible. It's finding galaxies, not just any galaxies, but massive, mature galaxies already teeming with stars, just a cosmic blink of an eye after the Big Bang. Now, this is a problem. You see, our current understanding of galaxy formation suggests that galaxies evolved slowly, gradually pulling themselves together from clouds of gas and dust over billions of years. Finding these fully formed galaxies so early in the universe is like finding a bustling metropolis in the middle of a prehistoric jungle. It just doesn't fit the narrative. These ancient behemoths are challenging everything we thought we knew about how galaxies form and evolve. They're forcing us to ask some tough questions. Did these galaxies form differently than we thought? Were there some unknown processes at work in the early universe that accelerated their growth? These are questions we don't yet have answers to. And if finding mature galaxies in the early universe wasn't shocking enough, let's talk about their size. The James Webb Space Telescope is finding galaxies that are way bigger, way more massive than they should be for their age. I'm talking about cosmic heavyweights. Galaxies with masses billions of times that of our sun, crammed into a time period when the universe was still in its infancy. To give you an analogy, imagine a seedling growing into a giant sequoia tree overnight. That's essentially what we're seeing here. These massive galaxies shouldn't exist so early in the universe's timeline. They simply didn't have enough time to pull in the vast amounts of matter needed to grow so large. This discovery throws another wrench into our understanding of structure formation in the early universe. Our current models, which are based on the gravitational pull of dark matter, struggle to explain how these galaxies could have assembled so much mass so quickly. It's like the universe skipped a few chapters in the cosmic playbook. Chapter 3, Stellar Nurseries Gone Wild, a New Era of Starbirth. Now let's zoom in even closer and look at the stars within these early galaxies. The James Webb Space Telescope, with its incredible infrared vision, is giving us an unprecedented view of the stellar populations in these distant realms. And what we're finding is just as puzzling as the galaxies themselves. The stars in these early galaxies are different. They're not what we expected. Our current understanding of stellar evolution tells us that the first stars, the ones that formed in the aftermath of the Big Bang, were massive, hot, and short-lived. But the James Webb Space Telescope is finding evidence of stars that formed much later, stars that resemble the ones we see in our own galaxy today. This suggests that star formation in the early universe was a much more complex and varied process than we previously thought. It's possible that multiple generations of stars were born in quick succession, or that entirely different mechanisms of star formation were at play. Whatever the explanation, it's clear that the early universe was a much more active and dynamic place than we ever imagined. Chapter 4. The Universe's Dark Secrets, Rethinking Dark Matter and Dark Energy. All these unexpected discoveries, these early galaxies, these massive structures, these strange stellar populations, they all point to something profound. Our current understanding of the universe might be incomplete. And that brings us to the mysterious realms of dark matter and dark energy. Now, we can't see dark matter or dark energy directly, but we know they're out there because of their gravitational influence on the visible universe. Dark matter provides the scaffolding for galaxies to form, while dark energy is the force driving the accelerating expansion of the universe. the findings from the James Webb Space Telescope suggest that we might need to rethink the roles of dark matter and dark energy in the early universe. Perhaps dark matter wasn't as clumpy as we thought, allowing galaxies to form more quickly. Or maybe dark energy played a more significant role in the early universe, influencing the growth of these massive structures. These are just some of the tantalizing possibilities that astronomers are now exploring. Chapter 5. Rewriting Cosmic History. The evolving story of the Big Bang. So, where does all of this leave us? Well, in a very exciting place, actually. The James Webb Space Telescope, with its remarkable observations, is forcing us to rewrite the story of the universe. It's challenging our assumptions, pushing the boundaries of our knowledge and opening up new avenues of exploration. The early universe, as we're beginning to understand it, was a much more dynamic and complex place than we ever imagined. Galaxies formed faster, grew larger, and hosted stranger populations of stars than we thought possible. The cosmic timeline, as we currently understand it, might need some serious adjustments. And the most exciting part of all this is that we're just scratching the surface. The James Webb Space Telescope has only been operational for a short time, and it's already revolutionizing our understanding of the cosmos. As we delve deeper into the early universe, as we uncover more of its secrets, we can expect even more surprises, more challenges to our current theories, and more profound insights into the nature of the universe itself. The James Webb Space Telescope is more than just a telescope. It's a time machine, a portal to the early universe, allowing us to witness cosmic events that happened billions of years ago. It's a testament to human ingenuity, our insatiable curiosity, and our relentless pursuit of understanding the universe we live in. Stay tuned as we continue to explore the universe with the James Webb Space Telescope. The adventure is just beginning, and who knows what incredible discoveries await us in the vast expanse of space. Don't forget to like, subscribe, and hit the bell icon for more updates on the latest in space exploration.